All right, what do we have here? We have actually on my table here all the components we need to build a computer. I've had a lot of people over the years ask me exactly what does it mean, or what is it like to build a computer? Is it challenging? Is it difficult? Some people are just shocked when I say I build computers at a computer store, because I guess they envision of like a factory line with manufacturing televisions or some sort of complex electronics, and maybe build is not, and maybe they imagine kind of putting all the chips on. Hopefully you can see this camera okay. I'm going to try my best to stay in the field of view of the camera, but maybe imagine we're actually assembling the chips and soldering components on. But actually, it's actually a very simple process. Well, not simple, but it's a very easy process. Easy to learn in just a few minutes, and so that's what we're going to do today. We have actually on my table, I don't know if you can see my case over here. Let me slide my case over. We have, there in the corner there, we have all the components we actually need to build a computer. This is actually a computer for the classroom. And let me go over the parts, and then we're going to kind of show you how to assemble it all. Basically, this is the only thing you need. You could probably use some little cutters to cut wires. Not wires, but cut little plastic zip ties, but we may not get to that in this video. Okay, the first thing, probably the most important thing, and I need to, one important step here is to ground yourself when working on electronics. Static electricity can just completely shorten and zap and kill a component very quickly just by touching it. So I'm going to always try to touch metal here. In fact, what I'm going to do, and excuse me for a moment, I realize I need to run another cord here. I'm going to actually run a cord to a power socket in the wall. Well, don't have one there. We find one in here. That will actually take me to a physical ground, an earth ground in the, because you want to discharge static electricity. Sorry, I know you can't see what I'm doing, but I'm just plugging a power cord. And from there, I am plugging in a power supply. Why a power supply? Because it's, so what I'm going to do is I'm going to basically take a box just like you see here on the screen. I have a black one here, but this is a raw metal one. And basically I'm going to plug it in to the wall, because that's going to complete a ground, that third prong on your power cords. And then every time I touch electricity, no, I'm not going to touch electricity. Every time I touch an electrical component, I'm going to first reach over. I know you can't see this, but basically, how about this? Maybe if I leave it right here, you'll be able to see it. So I'm basically going to just discharge static electricity. This is not only metal, but it's also grounded, so hopefully we won't kill anything. And it's always a bad thing when you kill something when you build it. Most important item on the table. In fact, if you look, I see one. Can you see that? Yeah. 1, 2, 3, 4, 5, 6, 7 items really is all I have. You could throw in a few extra things that we'll talk about maybe later. I'm going to slide this over a little bit so that I can still. But basically, this is the most important items that you have to have for just a simple build. Number one, we have, let me ground myself, grounding, the CPU right here to center. In fact, let me zoom in on that. Can you see? Where's my camera? This is a CPU, very static sensitive. It's got little, like 250 or so different little pins on the bottom that connect to the motherboard, which this is the motherboard, which sockets the CPU. Kind of, they call it the motherboard because everything basically attaches to it. So this is going to go into the computer. This is a very, this is inexpensive. By the way, I'll talk about some of the prices here. This is a fairly low-end build. That processor is about $85 to $100. This is probably about a $60 motherboard, maybe $50, somewhere in that price range. You can kind of get a running total. But this is a motherboard. Number 3, ground myself again because I'm touching more static electricity. This is your RAM. Sometimes people call it the memory, the RAM of the computer. Hopefully you can see that okay. It's these little chips, little slots that go into the motherboard. This provides the temporary storage of your computer. So when you're in the middle of playing a game or browsing the internet, all the information that's on your website gets stored in memory. And so, and more importantly, you're typing your research paper, and you type 5 pages of it, and the power goes out, and you lose it because it was stored in temporary RAM, not in, until you hit the save button, your hard drive. This is permanent storage, kind of dusty because this is an old one. This is called a solid state hard drive. This is 128 gigs, I believe. So no, this is a 240 gig solid state hard drive. This is your permanent storage. This is when I want to keep files permanently. And when I say permanently, yes, we could have disasters or erase them by accident, but basically you hit save, you type, I want this to go to my documents, my pictures, my music, my desktop. All that is stored in this device right here. There's a little connector. One provides data, one provides power. And we have a power supply right here. This is what I was talking about earlier about touching to to ground yourself. Basically, this has one job. Convert the AC power that's coming out of the wall, which would go into the back of the computer right here, normal little plug, into a series of direct current, or DC, with all these wires. Now, it looks intimidating with all these cables, but they only go one place. So if you can find a matching spot for that, you've probably got the right place. So there are 1, 2, 3, 4, 5, 6, 7, 8, there's about 8 or 9 different plugs on this, and we'll talk about where they all go. Okay, and lastly, and it's actually not required, because if you've ever been in my classroom, and hopefully if you're watching this video you have, a case is not actually required, because I don't have a case on my computer on the wall. I didn't mention this cable here, but this connects the hard drive to the motherboard, so just a little cable. We'll talk about that in a moment. So this is the case. This may look familiar to you, but oops, it's upside down. So this is a case. By the way, I didn't talk about prices anymore on that RAM. The RAM is probably about $50 now. The hard drive is about $50, $60, and the case is about $30, something like that. The power supply was about $40. But I don't know if you can see, but this is a case. Let me tilt it upwards. This is the front. You may recognize it, the little red stripe there. So what we're going to do, let's get started, because we've been talking long enough. I'm going to take the side off, and hopefully different camera angles would have been helpful here, but we have one camera angle, and that is right here, one straight above the table. So inside you have basically an open area with some wires, more wires. That's kind of the name of the game, is wires, wires, wires. Some of this is power, but some of these are just, 2 of these are buttons for the power button that says turn on, and one of the buttons is the reset switch. So if your computer gets stuck, you can hit the reset. I think these computers have reset. These may not have, yeah, it has a reset button in the front on the case. So generally we do all this last, okay? So this is, I'm not a, I mean, some people go overboard in meticulous, PC build. We're going to go things fairly routine and simple here. Now, the one thing that's already been done here is these little gold standoffs. That is a mounting mechanism for the screw to mount the motherboard to the case. Sometimes the cases will not already have these, and you probably can't see that, but I don't know if that helps at all. Probably not, but you can see there's little brass kind of standoffs. So what we're going to do is, now one very important thing to do here is count. Because if I count in here, I get 1, 2, 3, 4, 5, 6. Now I'm looking at my motherboard, and I'm going to count. I'm putting the right orientation here. I'm going to count 1, 2, 3, 4, 5, 6. Let's see, 1, 2, 3, 4, 5, 6. Okay, so that means we have an extra. We may have an extra standoff in there that we don't need. 1, 2, 3, 4, 5, 6. I'm just counting 6. So let's see. Because what can very commonly happen is you install a brass standoff where it's not supposed to go, and brass or metal hits the backside of these and it shorts out and it can fry something. I just miscounted earlier because I have 1, 2, 3, 4, 5, 6. I only have 6 in there. So we're just going to slide this little motherboard in here. It lines up with these back panels. Let's see if I can turn this upside down. So if you can see, the general thing you have to worry about is lining up all of these, the video, USB, where the keyboard goes in, the video, the sound. Those have to line up with all those openings, otherwise you won't be able to plug anything in. Okay, I think I have it plugged in basically. Now some things I'm going to try to speed up, so hopefully you won't have to, this won't be the entire time it normally takes me to build a computer. Now I don't know if you can see over here, I have a set of screws over here. There are different sizes of screws in computers, only maybe 2 or 3 are common, so I know that I need to use this little tiny one right here, and I'm going to put the first screw in right here. Now sometimes the order, it doesn't really matter. Sometimes I put the power supply in first, sometimes I put the hard drive in first, sometimes I generally put the motherboard in first, but it really doesn't matter. Some people put the CPU, I have not put the CPU in. A lot of people put the CPU in first while it's outside of the case, and that's probably a good idea too. I just generally go right for the motherboard, and I'm going to stop talking now so I can speed this video up later on so you won't have to watch me just put a bunch of screws in, which is not very exciting. If I have something interesting to say, I will resume the speed. Alright, let's count. We got 1, 2, 3, 4, 5, 6 screws. That was the same number that we started with, the little plug. So this is a fan. This is the power connector for a fan. Basically, computers get hot. CPU, specifically, that chip right there, gets very hot. On average, a chip like this will run about 40 to 50 degrees Celsius. and it's not uncommon for a chip to get upwards of 70, 80, 90 degrees Celsius. So I know you're probably not good with Celsius, but what is 100 degrees Celsius? 212 Fahrenheit, boiling. So that's not boiling because there's not liquid involved, but it can almost get, 180, 190 degrees. So these get very hot. So there's a couple things, I'm not sure if I mentioned this earlier. We have a fan that sits directly on top of the CPU. The fan is sitting on top of what's called a heat sink. A heat sink is just a series of fins of metal that spreads the heat out over larger surface areas. There's a physics principle that says that you can lower the overall heat by just distributing the heat over a larger area. So sometimes if you look at electronics on the back of your refrigerator, you'll see large chunks of metal. Amplifiers, a lot of times have these chunks of metal to distribute the heat. And on top of that, there is, and I think this one's still pretty good, what we call thermal compound. This is this little gooey material right here in the center here that just makes a good, close, very good bond between the chip and this heat sink. We don't want any heat to escape where it can just build up in one spot and overheat. We want to make sure that all the heat from the chip distributes to all the heat sink, and then the fan blows the hot air away, and this fan right here kind of pulls it out of the back of the case. There's also room in the front. We don't have one for another fan that could pull air from the front to kind of create a wind tunnel through it. So this fan connects to the motherboard. The reason they connect to the motherboard, not just the power supply, is you can actually have the computer control the speed of the fan. When your computer's not very hot, you may not want it to run full speed so it's not so loud. Then as the chip gets hotter, the motherboard can say, we need to turn that fan faster, and it'll just ramp up the fan. So that's kind of why it's controlled. It's connected to the motherboard, not just a power connector. All right, let's go ahead and put in the CPU. This is the central processing unit. This is an i3, if you want to know the details, i3 7100, which is one of the lower end, but we had to buy, 15 computers at one time, so we really couldn't be too choosy on. Now the important thing here is, besides grounding, is that there are little arrows and little notches in the CPU that tells you the direction. I know it won't show up on the camera, but down here there are also notches that correspond to this. So I'm going to, if you bought, some CPUs don't have the thermal compound, you just have to buy some and put it on there, but ours has enough on there from the last use. You got to be very careful, because if you put that in there and you kind of push it the wrong way, you can bend a pin over. When I say a pin, imagine a pin, 30 times smaller than your fingernail, and it just gets bent sideways. It's very, very difficult to fix that. All right, so that clamps it down, so everything is nice and connected. We're actually over halfway done, so that you can see it doesn't take that long. The fan basically has these little clips on there, so they just kind of slide in here and find the holes there, and you have to listen for the click. If it doesn't click, it didn't latch. If it didn't latch, we actually had a customer last week that didn't latch their CPU. The fan fell off while it was being used, and it overheated and killed the motherboard. So listen for this little ratchet sound. Oh, 1 second. Okay. Let's see if we can make that ratchet sound. Oh, these are kind of weird to I know you won't be able to see this. I wish I had a light that zoomed in better, but you have to turn these little notches. You turn one way to take the fan off, you turn the other way to put the fan on. So, all right, let's see if we can, I'll be quiet so you can hear this little ratchet sound. You hear that little sound? Sound again. 3 of them, now 4. Yep. All right, so that CPU is not going anywhere. It has the same power connector because it can also speed up and speed down as it needs. And these are, by the way, I mean, it's the only spot on the motherboard that would take a pin like this. So you can kind of, it's very easy to spot these. All right, let's go for the power supply now. All right, so this is a 400 watt EVGA. That's just the 400 watts is how much wattage it can handle. This computer does not, if you think about light bulbs, 60 watt, 90 watt light bulbs, that means that this computer can pull 400 watts before this power supply can't keep up. But these kind of components up here do not draw a lot of power. If you are a big gamer and you have a really powerful video card, you may need to put in a much bigger power supply, but we don't do a lot of complicated things. I'm using the black screws this time to screw in the power supply to the back. Again, you probably can't. Now, I remember from last time, these do not line up very easily, and I did not like the way they mounted. Looks like it's going to be the same way again. Yeah, they're just not, they just don't go in very, not a fan of, I think it's the case, it's not the power supply, it's the case that's just not, so I'll probably speed this part up as I might, I think it's going down too low, yeah, it's going down too far, so let's try to set this up a little higher. Okay, power supply is installed but not hooked up. I'm going to hold off on that for a minute. All these wires can be kind of, I don't know if you can see all these wires we talked about earlier. So I'm going to, whoops, just knock the screw off the table. That's a common problem of knocking something on the floor. Okay, I'm going to put the RAM in. Remember, this is temporary memory, so this is 8 gigs. I think there are 4 gigs on each stick. And, generally, you want at least 8 gigs in the computer. 16 is nice, 32 is even better, but 8 gig is a nice, now these kind of go in, there's a notch, there's a little notch here, I don't know if you can see this here, but there's a little notch, and the notch is not in the center of the piece, so it's slightly over to the left side, which so when I look at the motherboard, I see the notch in the motherboard is also a little bit to the one side, and that helps me line it up. I make sure one side's in, I click, put the other side in, click, memory is done. Alright, the last component we get to before we get to our cables is our solid state drive. Now these, you actually see these installed in a lot of different places. Sometimes they're on the back of the computer, kind of on the side, sometimes they're over in this area. In this case, and it's going to be hard to show this because it's kind of in the bottom of the case. Oh, let's see, let me try to move all these cables out of the way and extra. Alright, can you, you're not going to be able to see this, but maybe. Right down here at the bottom of the case are 4 places, so that's not exciting. I'm just going to screw those in. It's just going to screw right to the case, and I'll go ahead and fast forward this part as I'm just installing this hard drive. While I install this hard drive, let me talk a little bit about upgrades. Some people want to know, what's easy to upgrade in my computer. If I buy a computer, and we're talking about desktops. Laptops are different because they don't have as many upgrade options. But let's say you can't afford that dream computer, so you get as much as you can. Where can you hold back now and then kind of upgrade without having to start over later? And the hard drive is definitely one that you can always change later. As you can see, there's 4 screws. It does take a little bit of knowledge to transfer all your files over to a new drive. But as far as, it's very feasible. So you could buy a small drive and then upgrade to a bigger drive, a year from now. The memory, you saw me click those 2 pieces in. That's very easy to buy, 8 gigs now. And then, now on this motherboard, I only had 2 slots. Nicer, more expensive motherboards, one of the reasons you buy a more expensive one is to have more options for later. We may have 4 of these slots, which means I could put 8 gigs in now. 2 years from now, I could add 8 more. If I want to increase these, I have to take these 2 out and put 2 bigger ones in. So that's a drawback to the cheaper motherboards, but I don't anticipate changing that for a long time. The CPU is the biggest kind of gotcha. These CPUs can only jump a couple generations, every 2 or so years, and then you basically have to buy a whole new motherboard, which may require different size memory. So you really want to spend as much money as you can on this part now. I'm sorry, you probably can't see the CPU now, because you can't upgrade it very easily, and then even when you can upgrade it, the difference between what you can upgrade won't be that much different than what you bought originally. So I would buy the biggest you can now, and then the rest is the hard drive, the RAM, things like that you can upgrade later.